Hello, physics students. Welcome to the introduction to the lab portion of this course. This course we're meeting on campus. We'd have a 2.5-hour session scheduled per week in the lab where we would take data, analyze it, compare it to predictions, compare it to things in class. Well, this class isn't going to be like that. We're going to be stuck at home working on our labs. And different sections of this class are approaching this in different ways. Some sections are meeting with social distancing and public health procedures on campus. I'm not going to be setting foot near a college campus for a while. So we're going to do labs at home. Some classes are doing virtual labs. A virtual lab isn't a lab, it's a virtual lab. And just like virtual reality isn't reality, it's virtual reality. That's where you run a simulation, click on something, the computer does a little cute video and runs a simulation, and then you analyze that data. That isn't what I call an experiment. For instance, when you run a simulation twice, you always get exactly the same measurement. You'll see that when we do measurements, you're going to do it same measurement multiple times, and you very rarely will get exactly the same result. So that's the difference between reality and virtual reality. And this is not a virtual reality course, this is a reality course. But let me start with a little bit of history. What we call science and technology had a birth around 500 BC, or BCE as they say nowadays, in the Greek colony of Ionia. And there people started trying to understand nature by doing experiments. And these were merchants and seamen. They did experiments with their hands and thought about it. A very Ionian idea is the connection of your hands to your head and your heart. And they discovered all kinds of amazing things. They measured the circumference of the earth, for instance. They deduced by experiments that air was a material substance, even though you couldn't see it. And Herodotus traveled to Egypt. You know, the Egyptians at that time didn't know how old their civilization was. The pyramids had already been around for thousands of years, so as far as anybody knew, they were always there. And Herodotus, to help the Egyptians out, realized the Nile flooded yearly, and so he started digging a hole and counting the layers of floods in the hole, an idea that archaeologists and paleontologists use to this day by looking at layers to understand the age of something. And he deduced that the Egyptians were more than 2,000 years old. Anyway, most of their discoveries were stored in the Library of Alexandria because they were snuffed out. These people were snuffed out by the elite philosophers who thought you could understand nature by just ascribing things to the gods, a bunch of imaginary gods that they had, and just thinking upon things. Working with your hands was considered dirty and low life. So they were snuffed out by, I'll call them the mystics. I'd put Pythagoras, Aristotle, Socrates, Plato, those kind of guys. They kind of, we lost a lot of their material when the mystics burnt down the library at Alexandria. Anyway, that notion of using your hands to do experiments and understanding nature that way had a rebirth in 15th or 16th centuries with a man named Galileo. And that's where this course begins, with Galileo. Galileo started doing experiments, and we're going to do some experiments that Galileo did, very similar. And you know, you can still, if you just turn on the news, you can still see this battle between science and technology and mysticism. It's all over. It's still going on. Anyway, so we're going to do real experiments in this class. And as such, since we're not going to be on campus, we can't use the apparatus on campus, we're going to have to set up our own experiments. And that's going to make this kind of a unique challenge. These labs, the labs that I've made up for this semester, follow very much the ideas and topics that are covered in the labs that are done on campus, but we don't have as good of equipment, and we'll just have to make do. And so making do is what we're going to do. So what do we need? And they're having supply chain problems, and so they can't. They stopped taking orders for those lab kits, the labs at home kits, months ago. They're booked totally. But I found what we need is available on Amazon. The lab kits cost, cheapest one's $100. They go up to $600 to $700. I found what we need on Amazon for under 20 bucks. And so you're going to have to order a couple of items from Amazon. A lot of stuff you're going to have around the house and be able to just put together. So let's see what kind of stuff I'm talking about. A list of these things is all in the lab syllabus. First, safety. It's a set of safety glasses. Many of you already have a pair of these. If you've taken a lab course in high school or in college before. But they're not very expensive. There's a link to a pair on Amazon for a couple bucks. These labs have been devised with safety in mind. The most dangerous thing we're going to use is a pair of scissors, but you know, there are movies out there where people get murdered with a pair of scissors, so they can be dangerous. But as in all cases, safety is a big part of your responsibility. It's your responsibility to use these materials in a responsible fashion. I'm not going to ask you to use them in an irresponsible fashion, so it's up to you not to. Okay. So a pair of safety glasses. Let me get my camera going here. What else? We're going to need some paper clips. We got some big paper clips, little paper clips. Pretty common item. Little paper clip, big paper clip. We're going to need a ruler. We want a ruler that's got centimeters marked on it because we don't want to be converting from inches to centimeters constantly. We're going to need a big protractor. This is about 6 or 8 inches along the bottom there, so we need a big protractor like this. There's a link to one on Amazon, although I'm sure you can find these at Walmart or Target or maybe even the grocery store these days, Walgreens. We're going to need some marbles. Here's some marbles. I don't like this big one much. Doesn't matter exactly how big the marble is. So there's a couple of marbles. You know, if you see yourself saying, "Oh, I can't do a lab because I can't get a marble," then probably this course isn't for you. Because I think we have maybe 3 labs that use a marble, and so if you can't get one, you're going to get zeros on 3 labs. So if you can't get a marble, then this class is not for you. We need some kind of tape things down. This is painter's tape, and oops, this is painter's tape. Duct tape, masking tape. Duct tape might even be better. Duct tape is good in any situation, I think. Some marbles and some duct tape. Here's some double-sided tape. I can't think of an experiment that uses it right now, but it looks like it might be useful for some things. Double-sided tape. Some string. Here's a little bit of string. You know, fishing line would be real. I'm not a fisherman, so I don't have any fishing line. But fishing line would be really good, I think, for string. On a line, here's some thread. That could be useful. It's not very strong, but we might want to try some things with thread. And some rubber bands. Here's some rubber bands. Always useful. Okay, here's a stopwatch. If you can get one of these, I bought 10 of them. I bought, I think, 6 of them for $10 or something on Amazon. But they're for timing events, obviously. 0.41 seconds, 0.19 seconds, 0.22 seconds. My reaction time is about 1/10 of a second, and that's going to be an issue for us. You know, that's not an issue in, once again, if you're doing a virtual experiment, your reaction time's usually not an issue when you're taking a measurement. But in real life it is. And my reaction time's about 1/10 of a second. Takes for me to get the message to my fingers to press the button takes about 1/10 of a second. So the fastest I can do turn it on and off is about 0.2 seconds. That's 0.19 there. 0.12. Oh, I did really good on that one. This camera only stays on for 2 minutes, so it's going to be constant pain all semester. If anybody knows how to get a Samsung camera to stay on, please let me know, because I've researched it and it turns off after 2 minutes. Anyway, if you can't get a stopwatch, it's okay. Your cell phone has a stopwatch on it. Even if you got a flip phone, even flip phones in the 90s had stopwatches on them. But if you can get a cell phone that you can download apps on, like an iPhone or even a LG, any kind of Android phone, we'll be able to download some apps that will help us in this lab. So we'll be doing that. 2x4 board. I found this in my daughter's basement. About 6 to 8 inches long. I put a hook in the end of it, and that'd be useful at some point. Any kind of hook. This is an eye hook. But, you know, any kind of cup hanging hook or anything that you can dig up. Then we get to the most complicated item, specialty item. This is a spring scale that measures forces. It measures in newtons, and it measures from 0 to 10 newtons. Let me see if I can see the scale on here. Measures from 0 to 10 newtons, 1 to 10 there. Measures to 0.2 newtons, those small divisions are 0.2 newtons. So now I'm pulling with a force of 2 newtons. We're going to need this. You don't know what a newton is yet, but you'll find out. And we're going to need this about the 3rd week, so you want to get it ordered right away. We won't need it till about the third week of lab. This one I found on Amazon. It costs about I don't know, $14, $15 or so. A newton is, you don't know what a newton is, but 5 newtons is about a pound. So this has a maximum reading of about 2 pounds.
So we don't want to go weighing our cat with it or something, because you'll stretch out the spring. We want to be very careful not to even get close to 10 newtons on this force probe, because we're going to need it for a bunch of labs. And we want it to maintain its calibration. We don't want to ruin the spring that's in it, or wear out the spring that's in it. So be careful with it. It's pretty accurate. I've got some known weights that I hung on here, and they give it gives the right values. It's not. It says not for commercial use on it, I think, somewhere, but this is not a commercial use. We're not selling anything. Here's another one, 0 to 10 newtons that I found. You can, there's a description of the Amazon item in the lab syllabus for this, for you to order one. This is another 0 to 10 newtons. This one was only $10, but if you look carefully at the scale, it's only marked like every other newton, 2 newtons, 4 newtons, 6 newtons, and that makes it kind of hard to read, especially if your eyes aren't that good, like mine aren't. So this one's a little bit harder to read, but you can find this one on Amazon. Important thing is it goes 0 to 10 newtons, and it's a little cheaper, a little bit harder to read. You know, you might want to get these ordered right away, because these are the same scales that come in the lab kits. Those very expensive lab kits they send to do labs at home, and these could become hard to get. A lot of people are doing at-home labs, as you can imagine, throughout the country, throughout the world, as a matter of fact. Okay, well, a couple of other common things. Some empty water bottles. These are Gatorade bottles. Some water. Need that. And a board. I took this off of a bookshelf. It needs to be at least 34 inches long. Bookshelf boards, it needs to be flat. Bookshelf boards often are not very flat. You know how they start to get bowed because of books heavy books in the middle of them. So this one is kind of bowed. It's not really good. You can in fact see it's kind of bowed. This one is kind of bowed, but it's good enough. But if you can get a flat board, it needs to be at least probably 8-10 inches wide, but at least 34 inches long. We'll need that for a couple of labs. And you need a table. This is an old wash table. It's very old. You don't want to use your parents' nice dining room table, because we might be taping stuff down to it and stuff. So some kind of old table. You also want to have a table that you can kind of isolate from daily use, because sometimes we'll set up experiments one week and then use the apparatus next week, the week following that. So so you want to have a dedicated table. Rectangular is best, and this one's not very good, so if I can make do with this one, you ought to be able to make do, find something that will work. And I guess that's about it. That'll get us started. The first lab is just the first week of lab is just a computer exercise. You don't need any equipment for it at all except a computer. It's just a graphing so it's just the graphing. It's an introduction to the graphing software we're going to use in our labs for this summer. So the first week you don't need any equipment. Second week you're going to start needing some of this stuff. And that's it. So good luck, and I'll see you next week.